Whether they can pick up a bus, fly through the air, swing between buildings, or go invisible, mutations are thanked or blamed for many heroes' origin stories. But whilst this word has practically launched an entire genre of games, TV series and books, it's time we looked at what a mutation actually is and whether or not it can do everything that the comics say it can. So to understand what a mutation is, let's embrace our inner kid a little and play with Lego. Inside this box, I have little individual blocks, an instruction manual, and a picture of what the toy should look like at the end. If I want to create this, all I have to do is follow the instructions. And there we have it, a fully functioning police car that looks exactly how I want it to. But what if I skipped a step? Or if the last half of the booklet was missing? Or they gave me the wrong size piece? What would happen? Well, something like this. I guess something that doesn't work, or at least isn't entirely what I want it to be. And so I could break it down and start again to try and fix it, or give it to a friend, or perhaps I'm stuck with it forever. And all because I missed out or included the wrong thing whilst building it. And interestingly, this is very similar to what happens in our cells when they process mutations. Cells contain a nucleus that holds all of your genes. Now, genes are just instructions for how to make proteins and are written, rather than with words and pictures, in DNA. Normally, when a cell wants to make a protein, it'll get its nucleus to make a copy of the gene. This gene is called messenger RNA, or mRNA for short. A machine called a ribosome will then read along the mRNA and build the protein from building blocks called amino acids. Once the ribosome has reached the end of the mRNA, we have the finished protein. However, if there is a mutation in the gene, then the cell will place the wrong building block in that position, leading to a different protein. Some of these mutations can be subtle and can change the protein by just a couple of atoms, but some can be enormous and can completely change the nature of the protein, making it much larger or smaller than it should be. So what does this mean? Well, it means that some proteins can be changed so slightly that we barely even notice the effects. It's a bit like me removing the lights from the side of the police car. It's a very minor change. However, sometimes it means that changes are far more striking, which leads to the protein no longer working. It's a bit like me skipping half of the instructions and ending up with only half a police car, like we saw before. Or alternatively, it might mean that the protein takes on a brand new function, a bit like me reading the instructions wrong and adding a pair of wings to the police car so it can now fly. Ultimately, what effect a mutation has on the protein depends on what the mutation is and where it arises in the protein. So pulling all of this together, mutations are powerful drivers for change, leading to changes in protein structure and function in a similar way to how we can change how this Lego police car works by changing what blocks we swap into and out of it. So mutations can have a huge repertoire of effects and a lot of potential for how they can change an organism. But having said that, it is highly unlikely that a mutation would arise that would allow us to shoot lasers out of our eyes or to move objects with our minds. Unfortunately.